us what you have in those tubes right now.
So right now, the orange tube is hot water, and the other tube is cold water. We're going to put the same colors in, and we're going to see which temperature makes the dye like form faster in the water. So 3, 2, 1. Okay, I think it really looks like hot right now because...
Which one was the hot on this side?
Orange is hot right now.
Orange label?
Yeah.
Okay.
And then the green is cold.
Okay.
And it looks like green's definitely not going as fast as this one. That one...
You haven't bumped them or anything, right? All it is the temperature.
Yeah.
Do you know why it's doing that differently?
Because, like, the heat gets in there more, and it puts pressure in there, and it breaks into more pieces, and it just, the color comes out more. And cold really doesn't do that. Doesn't do that as much.
Let's see what the book talk says about this at all. It says, on the other lab, you just found out that a little bit of stirring makes a big difference. This simple little test demonstrates a really important concept in kinetics. For a chemical change to happen, the chemicals have to touch, no contact, and nothing happens. With no stirring, only the water directly around the tablet can interact with the dye, so the rate or speed of the mixing is slow. Turning on the mixer gets water moving over the tablet. As the water whooshes by, it runs the dye tablet more often. This increases the interaction. What you also saw with this heated versus cold water is a great example of why mixing machines... Oh, wait. Okay, I'm going to redo that one. So with the differences in the water temperature, it talks about solubility. Solubility is a measure of how much of something, say sugar, dissolves in something else, say a cup of tea. As you discovered, mixing is one way to make things dissolve faster. Mixing doesn't change the solubility though. This just means that no matter how much you mix, you can't keep adding sugar to the tea forever. Eventually the sugar just won't dissolve anymore.
And when you mix, like, it kind of makes it hotter, I think. Like, when you mix it and, like, shake it up and down, the water moves faster, and it gets kind of hot now.
Could be. So let's see. So in this one it says, in this experiment you just discovered that heat can also speed up the exact same change. Is that a coincidence? No, you just saw that heat and motion are related. In fact, heat is motion, the motion of molecules. The hotter a substance is, the faster its molecules are moving. For example, for water, a molecule is made of 2 hydrogen atoms and 1 oxygen atom, H2O.
So I was right. Like, it was moving faster, so it was heating up.
It says, in this experiment, the cold water is like a classroom full of kids walking very slowly. Each kid only passes one another once in a while, and they rarely crash. The hot water, on the other hand, is like if all the kids started running and crashing into each other. That's what you saw when you increased the heat. That increased the motion of the molecules, and that made the mixing go faster.
Yes! I am happy.